Hello and welcome back to the 6-6 Notes, Part 2. I do want to do the very last problem and talk about that. And it wants us to verify that this quadrilateral EFGH is a trapezoid. Okay, so I'm going to plot these points here. I'm going to plot the points 1, 3. Okay, for E, so that's 1, 3. And let's go ahead and plot 5, 0. 1, 2, 3, 4, 5, 0. Okay. And then let's plot 8, negative 5. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Right here. And then we've got the point negative 4, 4. Okay. So it's kind of an interesting figure. Okay, negative 4, 4. So 1, 2, 3, 4, up 1, 2, 3, 4. All right. So what I've got here, and let me zoom in and draw my points, or draw my segments from one to the next. Okay, there's that segment, and then there's that segment. We have this segment, and then we have this segment. Okay, and let me label the points as such. This is E, F, G, H. Okay, so this is going to be segment E, or point E. This is going to be point F. This is going to be point G. And this is going to be point H. Okay? So what I want to do first, to verify that it's a trapezoid, I want to show that the bases, the base lengths, are parallel. Okay? And so the first thing I want to do is find the slope of EF. Okay? And so what I'm going to do with that is I'm going to come over here and draw a right triangle. You can use the slope formula if you like, but I think it's easier if you've got this. So that's a go up 3, rise over run, so 4. So my slope for EF, okay, is going to be negative 3/4. Okay, and I'm looking for the same thing for HG. Okay, so I found the slope of EF. Okay, let me find the slope of HG. Okay, I'm going to come and do the same thing. I'm going to draw a right triangle. I'm going down to here and then over to here. Let's count those lengths. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a 9. And then let's go over here. A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So a little bit different. This slope is negative 9/12. Okay. M is equal to negative 9/12, but that can simplify down to negative 3/4. Okay, so the slopes, okay, these slopes are the same. Okay, so they're the same. So because you have one segment, one pair of segments that are parallel, then you have a trapezoid. So I'm going to say this. My conclusion is that EFGH is it's a trapezoid because one pair of opposite sides are parallel. Okay? And that's all I'm looking for. All right? And then it wants to know, determine whether this figure is an isosceles trapezoid. Okay, so what I want to do is I want to then show that the legs are congruent. Okay, so show that the legs are congruent. So I want to find the distance of HE. Okay, so I want to find the distance of HE. Okay, so let's go ahead and do that. Let's go ahead and draw in our right triangle over here. And so I'm going to go over from this point and then down one. So it's a 1 by 1, 2, 3, 4, 5. So it's a 1 by 5 triangle, 1 by 5 right triangle. Let me use Pythagorean theorem to do that. So HE is equal to the square root of 1 squared plus 5 squared. So HE, let me rewrite this in blue. HE is equal to the square root of 1 plus 25. So HE is equal to the square root of 26. Okay, I'm just going to leave it like that. And then, so that's my first one. And then in the next one, I want to find what the distance of FG is. So I'm going to come in here and write that. Okay, I want the distance of FG. Okay, so let me do that real quick. And let me come in here and draw this. And we may not get the same thing, so I don't think we do, actually. I think it's a little bit different. But this goes over 3 and then down 5. So 3, 1, 2, 3, 4, 5. Okay, so it's a 3 by 5 right triangle. We already kind of know that they aren't. Let's go ahead and calculate that, though. That FG is equal to the square root of 3 squared plus 5 squared. So FG is equal to the square root of 9 plus 25. Okay, so that is going to end up giving me square root of 34. Okay, so what we can conclude here about this distance is that these two segments are not the same. Okay, so therefore we can conclude that the legs are not congruent. So then we can conclude that, what's the name of this thing? EFGH, so that legs are not congruent. So EFGH is not an isosceles trapezoid. Isosceles, it's a trapezoid. Okay? So that's all I've got for chapter 6. And that bell means, folks, that it's time for lunch. Now get to work.